Hello, Year 10. Today we are introducing logarithms. But before we do, let's quickly do a few review questions from last lesson. Question 1. House prices in the city suburbs are rising at a rate of 8% per year, and Caleb's villa is currently valued at $950,000. So I've put on there that the R is equal to the 8% and the A0 is 950,000. Our formula when the amount is increasing or rising is A equals A0 bracket 1 plus R over 100 to the power of N. Subbing in what I have, A0 is 950,000. Then we have 1 plus 8 over 100 to the power of N. We are asked to call this a V for value equals 950,000, and simplifying that bracket we would get 1.08 to the power of N. So what will be the value of the villa next year and in 4 years? Okay, so I think that's two things that we need to do there. Next year we'll be subbing in that N is equal to 1. So we get V equals 950,000 times 1.08 to the power of 1. Typing that in our calculator, we get 950,000 times 1.08 to get 1,026,000. Okay, then in 4 years' time, we just need to change the power on the end to be a power of 4. So retyping that in, we'll just use a back arrow here, and we go power of 4. So it's now 1,292,464.51. Okay, so time for some logarithms. On your calculator, there is a button that says the word log. So L-O-G, log. That is for logarithms that have a base of 10. So you see this here, we have a log with a little 10 down the bottom of x, or sometimes they might even skip the 10 and just write log x. Either way, both of those things mean a base of 10, and we use the log button. So to practice that on our calculator, we're going to type in log base 10 of 5.7. So the log base 10 just means we push the log button. Doesn't show you the base 10 part, but then you press 5.7 and equals, and so that is equal to 0.7559 if I do 4 decimal places. Logarithms can be rewritten into index form and vice versa. So we can turn a logarithm into an exponential equation is what that means. So what we do here, there's a formula here, and we call this the sliding base rule. So what happens is if the A is the base of our logarithm, whatever that number there happens to be, when you turn it into an exponential, it slides across to the other side and is also the base of the exponent. But you're sliding it across to this side with the y. Okay, so it's the base A of y to the power of y is equal to x. Okay, so let me try to show you how to use that in example number 1. So it says to rewrite this in logarithmic form. So the 2 is the base of the 5. So the 5 is going to stay where it is, and we slide the 2 across to the other side to become a log base 2 of 32. And that's it. That's what you call a sliding base. Let's try that again. Part B. To turn this into a logarithm, the 3 stays where it is, but the base of 5 slides across to be the base of the logarithm of 125. Okay, on to question 2. we want to change these logarithms into index form, which means we want to slide our base across to the other side again. So that will turn it into an exponential type equation or a power. So the 81 will stay where it is. The 3 slides across and it is the base of the 4, so 3 to the power of 4. The next one, the 1 million is going to stay where it is, and the base of 10 slides across to the other side to be to a power of 6. And it makes sense that 10 to the power of 6 is equal to 1 million. Question 3, find the value of the following. So what a logarithm is really asking you to do is to ask yourself the question, 2 to the power of what gives 16? So you could say, well, I know 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16. So the answer to that logarithm is 4. However, that can be a tricky thing for some people to do in their head. So if you are ever stuck and you go, I can't do that one in my head, then what you can do is you can turn your logarithm into an equation. So you can call it x equals log base 2 of 16, and then we can slide our base over. So 2 is the base, so 2 is going to slide over and be the base of the x, and it will be equal to 16, and then we solve it as an exponential equation. So turning the 16 into a base of 2, it would be 2 to the power of 4 that makes 16, so x is equal to 4. So whether I do it in my head up here or I turn it into an exponential equation, I get the same result. So let's try to do B in our head. The logarithm is asking you to say 10 to the power of what gives 10,000. So you could sit here and guess. You go 10 to the power of 3, that only gives me 1,000. So if I want 10,000, I have to go to the power of 4. So again, for this one, that is going to be equal to 4. Question 4 is all about solving them as equations. It says to solve each logarithmic equation by changing it into index equation. So that means we're going to be sliding the bases across. So for the first one, x equals log base 5. We slide the base 5 over to the other side and it will become 5 to the power of x is equal to 1/5. Okay, then we need to make the bases the same. So this 1 over 5, we put a little power of 1 on that 5, which means that we could rewrite that as 5 to the power of -1. Once they are both base 5s, we compare the powers and we know that x is equal to -1. Let's do question B. To slide the base, the 27 is the base, so it'll be 27 to the power of 1/3 will be equal to x. Because the x was in a different spot, my equation looks a little bit different. A power of 1/3 is the same as a cubed root of 27. And the cubed root of 27 is 3. Question C. X is the base, so we're going to leave the 12 and we're going to slide the base of x across to the other side, so it'll be x to the power of -1. Then, to solve that equation, I'm going to get rid of the negative power of 1 by turning it into a fraction. It would be 1 over x to the +1 times the x over to the left-hand side, 12x equals 1, and dividing by 12, we get x is equal to 1/12. Question D. Sliding the base x across, we'll have 9 equals x to the power of -2. Turn that negative power into a fraction by becoming 1 over x squared. Times the x squared over to the left will become 9x squared equals 1. Divide the 9 and we get x squared equals 1/9. To get rid of the squared, we need to square root 1 over 9, which means we square root 1, which is 1, and square root 9, which is 3. But when you square root something, remember that it could be a plus or a minus. However, for a logarithm, you can't have negative values of x when you put that back into your logarithm. So even though when we solve the quadratic, we can have a plus or minus, the negative solution will not exist in this case. So we're just going to have x is equal to a positive 1/3. Question 5. Solve each index equation by changing it into a logarithmic equation. So we're going to slide the base 10 over. X will stay where it is. It'll become a log base 10 of 125. Now, a log base 10 is something that we can do on our calculator. So we press log, and that means a base 10. Then we do 125 equals, and it would be 2.097 if I just do 3 decimal places. And for part B, to get the x by itself, I slide the base 10 over to be log base 10 of 0.123. Okay, again, because it's a base 10, it can go into the calculator. Log of 0.123 is negative 0.910. Again, that's doing 3 decimal places. Okay, so that's an introduction to logarithms. Your turn to do exercise 3H.